Hello, welcome to episode 9 of getting started with attributes and VOPs inside of Houdini series. And in this one, I'll be showcasing a couple of new things that you can do with VOPs, including the fact that we can use sine and cosine function inside of VOPs, and of course that we can do selections based on attributes using the groups node. And as a result, we will have this kind of alien looking structures based on simple geometry. You can see we can do it on the cube, like octahedron, and any other geometry really. So this should be really fun. So before we start, I want to say that if you're interested in supporting the channel, the best way would be to maybe check out the Patreon page, because it has all the setups, all the files that you can use for your own tweaking or just, following step by step. If you're not interested, it's fine. Maybe just consider hitting the like button and subscribing. And without further ado, let's recreate this network from the ground up. Now, before we begin, I want to show you how you can use sine and cosine function. And I want to say that it is not mandatory to use exactly everything like I do inside of this video, because you're welcome to input your own parameters, your own noises, your own tweaks, anything, because this is not, like this is how you do it. There is no other way of doing it, right? No, of course you can use it, input your own parameters, do whatever you want. It's just a workflow. So in case you were wondering if you want to tweak it any further, let's start with the grid. And as you can see, grid, well, it does what it says. It creates a grid, and drop an attribute VOP as per usual. Jump inside. And I want to showcase, actually, let's scatter first so that we have just randomly arranged points. Okay, so we have very, very randomly arranged points. However, we can make them sort of behave, and we can arrange them in a circle using sine and cosine functions. First, we will divide the vector of position into constants using the vector to float. So we can add vector. As you can see, we have values. Then we get float to vector. We connect it back. And if you watch this video, you already know the result will be we pipe the position in, do something here, and we get the position out, and we will have our result. So we get the sine, and we get the cosine. And of course, we will use the easiest way to do that will be to use the point number that will feed into sine and cosine. So we get the point number, get it here, get it there. And of course, if we get the sine into the x and get the cosine into the y, we'll have a tube. Or, for example, if we get it into the z-axis and we connect y to y, so basically the height will be as it was, basically 0, you will see that we indeed have a perfect circle, which is pretty cool. Now, how can we use that to generate our weird looking alien geometry? It's pretty easily, actually. So let's start with the platonic, because they look kind of cool, right? And tetrahedron will do just fine. Next, I will be just going through the whole stack we have on the left and explain how I got the results that you are seeing. So subdivision. You will see that we can subdivide to the different level of depths. And obviously, subdivision smooths all the geometry, and we don't really want that. We want to preserve the kind of sharp outlook of what we had in this platonic. As you can see, currently it looks very different. However, there is this button that says override crease weights attribute, and as you can see, we can actually crease the edges, and subdivision will take into account that the edges are creased and treat them as kind of borders for its smoothing. So we can now subdivide it, for example, by 7. 7, maybe it will be fine, maybe not. We can obviously tweak it a little bit later, so we can see what's what. So next up, we drop, finally, attribute VOP. So inside the attribute VOP, we'll first create our noise. In this case, I think we will be using anti-alias noise, just because we previously used the turbulence, the Voronoi, the something else noise. In this case, let's just use AA noise. And we will displace along normal using that noise. So We get the position here, displaced position here. As you can see, nothing really is going on just yet. However, if we get our position into noise and noise into the amount of displacement, you will immediately see that indeed it kind of affects our geometry in some sort of a way, right? However, as you probably know, the position that we feed into the noise, as you can see, it has an input. So basically we can do whatever we want with that. And indeed, I want to use the sine and cosine, maybe. We'll see what works best. So the first thing I want to do is to convert vector to float so that we can tweak our... So as you can see, there is the noise, it has offset. So let's try to actually manipulate the offset using the sine function. So let's get the position into our sine. And of course, we can do float to vector to combine back the floats and fit it into the offset. So here's what we're going to do. Let's move it to the left a little bit so we have a little bit more space and get the add function. So first, connect these three. Should work as expected. As you can see, something's definitely going on, right? However, if we get the sine function, for example, in here, we get the value 2, add it to initial value, kind of like this, whoops, and fit it back into the value. You will see that we do indeed have some kind of funny looking result, right? So we can feed this not into the y, we can feed it into, for example, in the z-axis, connect y back, and indeed you see that we are adding these kind of streaks throughout the whole geometry. So initially, as you can see, we already can use that to create some sort of crystal type geometry or kind of rocks that were created by sediments or any other, way of natural occurring formations. So what we can do with the anti-alias noise now is we can increase the offset, we can increase or decrease the roughness. Everything here is more or less self-explanatory. We discussed how to use that, how to what these tweaks do, but if you're a little bit new to this, you can safely tweak it. Even if the geometry gets destroyed like here, it will not be a problem. Why? Well, because we will first, as you can see here, I attribute blur the position. So let's do that again. It will help us measure the curvature later on. So as you can see, we can blur out our result of our distortion with the noise. So next up, we will get the normal so that we can safely measure the curvature. So we get the measure. We can use the measure curvature. We can use just the measure. It doesn't really matter. I will be just using just measure, so to speak. And I can press enter and I'll see the results in the viewport. So what are we measuring is we are measuring curvature. You will see that we can tweak the different results so we can see how it mapped differently here as well. It's just for your personal visualization. What we really need is we can bake visualized ranged output and remap it from 1 to 0. So what is happening, right, is we can split the top to bottom and get to the geometry spreadsheet. You'll see that we have primitive attributes that are called curvature. Again, we go to the primitives. Indeed, here is our curvature, and we can filter it. You'll see that indeed our curvature goes from 0 to 1. So what we're going to do next is we drop a group node, and the base group we will be getting the primitives, and the group will be saying that anything with curvature bigger than something, for example, attribute curvature bigger than 0.4 or 0.5, missed the key there, will be the curvature, will be the selection that we need. So next up, we can blast the group. As you can see, we can leave the things that we selected, or we can invert it and delete the non-selected. As you can see, already we have some sort of thing going on. I'll just collapse it because we don't need it really. So obviously, if you go back to the group and you increase or decrease the selection of the curvature, for example, anything with curvatures bigger than 0.3, you'll see that we have different geometry, different selection. More than 0.9, for example, there will be, as you can see, only the really sharp curves will be left. And of course, everything else will be deleted. However, maybe let's do the 0.6. Okay, next up, you see that here I booleaned. Why did I do the boolean? Because I wanted to boolean union the geometry. So what it means is that if the geometry by the virtue of our kind of like haphazard selection, to be honest, for example, if we do it like 0.4, there will be much more geometry, and sometimes this geometry might get a little bit problematic. So using the Boolean union will kind of glue together different parts of geometry if they intersect somewhere. So that'll be less problematic when you're doing the poly extrude. Now the poly extrude part is somewhat interesting because if you're just starting to poly extrude, you'll see that our geometry is looking very weird, very wrong. But if we do it by point normal, you'll see that everything kind of fixes everything together back magically, so to speak. So basically what I'm saying is if you're poly extruding broken geometry like this, because this is not good geometry, right? If you're just starting out with, working with geo or whatever, if you see something like that, right, you'll just, this is going to be a lot of problems. So anyway, if you're running into problems with, for example, poly extrusions, or you will absolutely run into problems with booleans or whatever, you'll see that, this is not good at all. So make it point normal, everything should be good. So next up, we will convert it to VDB from polygons. And of course, this resolution is 2 cores. So let's try to 003, maybe even 001. Again, I don't think that's enough. Let's add some zeros a little bit here and there. And you will see that indeed we have some sort of surface already happening. However, to make it a little bit more smooth, we go VDB smooth, as the name suggests. However, we should make the iterations like 1. But you'll see that, again, this destroys a little bit too much. So what we can do is either increase the amount of poly extrusion so that we can convert it and we get more kind of like a volume, or we can increase the resolution of the volume data. So again, if you make the voxel size smaller, it will increase the resolution, as the name suggests. Okay, so we have this. I think we can increase the amounts of extrusion a little bit more, so we have a little bit more geometry. We can tweak it later. For now, let's convert VDB back to polygons. You'll see that indeed we have some sort of somewhat interesting looking geometry. And of course, sometimes geometry that you convert, you cannot see it. So you can actually tweak the ISO value to be higher or smaller. This will work, I think. Increase the voxel resolution. This kind of looks a little bit too wonky. Let's maybe make it 0.3. And here, let's decrease the extrusion itself. Okay, I think we can work with that. And of course, we can attribute blur. And now we'll blur the position again. Kind of like this, right? You'll see that indeed we have the geometry that we were kind of striving for. And finally, as you can see, there is a mesh sharpen thing. Mesh sharpen is a labs. Mesh sharpen is a labs node from SideFX Labs, and what it does, it basically does what it says. However, in the defaults, mesh sharp is a little bit, well, sharp. So what we can do is decrease the amount of iterations to make it affect our geometry a little bit less. And of course, after sharpening, there is a post smoothing. Again, does what it says. So this again is up to you how you want to tweak it, how you maybe not want to tweak it. So the point is, here is our geometry. It looks a little bit different from the one I showcased at the start of the video, basically because, well, you can tweak your noises differently. You can increase or decrease the amplitude, which will, of course, drive how our selection of the group gets selected. Of course, I can make anything bigger than 0.5. As a result of that, we will have much less geometry to work with. However, if we do our, procedural thing, you will see that at the end we have our alien structure, which is a little bit thinner in these places. We can switch the platonic, for example, from tetrahedron to, for example, octahedron. It will be kind of like in this diamond shape right now. As you can see, this looks really interesting. Obviously, you can tweak it however you want. And of course, we can use our test subject swap. However, just keep in mind, we subdivided our geometry 7 times with a crease weight of 3, and we went from 8 polygons, right, to 100,000 polygons. So that's a lot of polygons. And if you try to do the same thing, subdivision with squap, you will run into, well, probably your Houdini session might crash, or you'll run out of RAM and crash. So either way, you can crash is all I'm saying. So if you have the squap geometry, I think like we already have 20,000 polygons right here already. So maybe this will be enough to do our thing. So let's see. Pretty much, I'm sure it will be working fine. Just all I'm saying is, if you are doing a lot of subdivisions, do not expect to feed any geometry. Just be careful, because this might not end well. So anyway, as you can see here, I think it is getting blasted a little bit too much. So in our group selection, I think we can increase the amount of geo that we have initially, so that our squap does not get destroyed that much. We can evaluate our results. So as you can see, any geometry will work, but maybe something that looks very, very, very primitive, very geometric from the get-go might yield somewhat more unexpected and interesting looking results, because you would expect that this kind of stuff, again, it's not looking terribly bad, but the initial geo is not preferable to my personal point of view, because it does not follow some sort of rigorous structure that we get from super basic geometry like tetrahedron, octahedron, or cubes, maybe some spheres or whatever. So there you go. Again, just to review, we get the geometry, we do the attribute VOP, we displace the geometry along the normal using the noise. However, the noise itself is being controlled on the offset, where we control it using the sine function, which gets the data from the position of the point. Again, if I just explain it like that, I know it sounds kind of like too much wording, but when we do it, you will see that it's not that hard. So there you go. And of course, finally, what we did is we got a new attribute, curvature, which we actually literally we got our geometry and measured the curvature, and then we wrote this curvature into 0 to 1 range of attributes, and we got our attribute curvature, which allowed us to select primitive based on that curvature attribute. And of course, we can then blast or delete the selection of or anything that's not selected, and use that to create our geometry. Hopefully you learned something useful, and hopefully you like it. If you like it, well, basically press the like button. If you have ideas, suggestions, don't hesitate to leave the comments below. If you're interested in learning more, don't forget to subscribe to the channel. With that said, I hope you're having a nice day and hope to see you in the next video, and bye-bye.